So next topic is diagonalization of matrices. Quadratic format is a homogeneous polynomial of the second degree in any number of variable is called the quadratic form. Example is 2x1 squared minus 2x2 squared plus 4x3 squared plus 2x1 x2 minus 6x1 x3 plus 6x2 x3. This is our quadratic form. So our quadratic form is transformed to matrix type. How do we transform quadratic form to matrix type? The format is here: coefficient of x1 squared, coefficient of x1 x2 by 2, coefficient of x2 x3 by 2, next coefficient of x2 x1 by 2, coefficient of x2 squared, coefficient of x2 x3 by 2. Next row is coefficient of x3 x1 by 2, coefficient of x3 x2 by 2. Next is a coefficient of x3 squared. So our sum is write the matrix of the quadratic form. This is our quadratic form: 2x1 squared minus 2x2 squared plus 4x3 squared plus 2x1 x2 minus 6x1 x3 plus 6x2 x3. This is our quadratic form. Here we write matrix type. Matrix type format is this is one quadrant coefficient of x1 square, that is 1. Coefficient mean x1 square, coefficient of x1 squared is in quadratic form is 2. So we write first one, first column element is 2. Next coefficient of x1 x2 by 2. Here the quadratic form x1 x2 coefficient is 2. 2 by 2 is 1. So first one, second column is 1. Next coefficient of x1 x3 by 2. So coefficient of x1 x3 is minus 6 divided by 2, we get minus 3. So first row and third column element is minus 3. Next we find second row. Second row format is coefficient of x1 x2 by 2. x1 x2 coefficient is 2. 2 by 2 is 2 divided by 2 is 1. So second row and first column element is 1. Next we find x2 and x2 element is x2 squared coefficient is minus 2. So we write minus 2. So second row and second column element is minus 2. Next we find coefficient of x2 and x3. Coefficient of x2 and x3 is 6. 6 by 2 is 3. So our element is second row and third column element is 3. Next we find third row. Third row first element format is coefficient of x3 x1 by 2. x3 coefficient of x3 x1 is minus 6. Minus 6 by 2 is minus 3. Next element format is coefficient of x3 x2 by 2. x3 x2 coefficient of x3 x2 is 6. 6 by 2 is 3. So third row and second column element is 3. Coefficient of x3 squared is 4. So our third row and third column element is 4. This is our matrix. Here we write quadratic form to matrix type. Next our example is write the quadratic form corresponding to the matrix. This is our matrix, given matrix. Here we write quadratic form mean. Next, index of the quadratic form. What is index of the quadratic form? The number of positive square terms in quadratic characteristic equation. The number of positive square terms in canonical form. It is denoted by S. So index we denote S. Our index is the number of positive square terms in canonical form. CF means canonical form. Next is signature of the quadratic form. Number of positive term in canonical form minus number of negative terms in canonical form. Next one is nature of quadratic form. Positive definite if all the eigenvalues are positive. Our all eigenvalues are positive, we write positive definite. Negative definite is if all the eigenvalues are negative, we write negative definite. Positive semi-definite if all eigenvalues of a greater than or equal 0 and at least one eigenvalue is 0. At least one eigenvalue is 0. Next, negative semi-definite if all eigenvalues of A less than or equal to 0 and at least one eigenvalue is 0. Indefinite if A has both positive and negative eigenvalues. Indefinite if A has positive and negative eigenvalues. Canonical form is Y transpose D into Y. So our next first sum is reduce the quadratic form into the canonical by using orthogonal transformation. This is our quadratic form forming. Next our solution is, first step is we transform to quadratic form to matrix form. A equal to 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. All types are having same steps. Our first step is find characteristic equation. So our format is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. S1 is sum of main diagonal elements. Our solution is 18. Next, S2 is sum of minus of main diagonal elements. Solution is 45. S3 is determinant of A. Solution is 0. Applying characteristic equation. So our characteristic equation is lambda cube minus 18 lambda square plus 45 lambda equal to 0. We take lambda in common. Lambda into lambda square minus 18 lambda plus 45 equal to 0. So our first root is lambda equal to 0. Next we find lambda square minus 18 lambda plus 45 root is lambda equal to 3 comma 15. So our eigenvalue is 0 comma 3 comma 15. Next step is we find eigenvectors. Format is a minus lambda I into x equal to 0. We apply A and identity matrix in previous step. We get 8 minus lambda minus 6 2 minus 6 7 minus lambda minus 4 2 minus 4 3 minus lambda into x is eigenvector x1 x2 x3 equal to 0. First eigenvalue lambda equal to 0 in applying in equation 1, we get 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3 into x1 x2 x3 equal to 0. Using cross multiplication we find first eigenvector is 1 2 2. Next we apply eigenvalue lambda equal to 0. We get minus 5 minus 6 2 minus 6 4 minus 4 2 minus 4 0 into x1 x2 x3 equal to 0. Using cross multiplication we find second eigenvector 2 1 minus 2. Next eigenvalue is lambda equal to 15. Applying in equation 1 we get minus 7 minus 6 2 minus 6 minus 8 minus 4 2 minus 4 minus 12 into x1 x2 x3 equal to 0. Using cross multiplication we find third eigenvector is 2 minus 2 1. So our eigenvalue is 0 3 15. Eigenvector is 1 2 2 2 1 minus 2 2 2 1. Next we check this matrix is orthogonal or not. This is orthogonal. We proceed next step. Our next step is normalized form. First we find L equal to root x1 square plus x2 square plus x3 square. So our first eigenvector is 1 2 2. Here we take root. Our solution is 3. So we write 1 by 3 2 by 3 2 by 3. Next is 2 by 3 1 by 3 minus 2 by 3. Next one 2 by 3 minus 2 by 3 1 by 3. So our normalized matrix n equal to 1 by 3 2 by 3 2 by 3 2 by 3 2 1 by 3 minus 2 by 3 2 by 3 minus 2 by 3 1 by 3.